Warm up 1C. We're going to sketch a graph and include critical points. I've got an absolute value function here. I'm going to start by finding the vertex. So I'm going to take the whole contents of the absolute value, which is the quantity x minus 2, and I'll set that equal to 0. And then I'll solve for x by adding 2 to both sides, and x equals 2. That's going to be the x-coordinate of my vertex. The y-coordinate is whatever is added or subtracted to the end. So my vertex then is going to be the point 2, 1. 2, 1. Okay, there it is. And I can tell this one is going to open upwards because there's no negative in front of the absolute value there. So that means that it opens up, and also there's no coefficient in front of the absolute value or in front of the x. So there's no stretch or compression. So that means to get to the next set of points, I'll go up 1 to the right one, and up 1 to the left one, and you could go up 1 to the right one again, up 1 to the left one again if you wanted. You really only need 3 points to draw a nice graph as long as the vertex is one of them. And we do have the vertex here, and there's a graph. Okay, on the next side, let's look at writing some functions. So I'm going to be writing function g in all of these. So g of x on this first one, it says we're going 2 units to the left. So I'm going to take function f and do something to it. When we're going left and right, we're adding and subtracting to the input inside the parentheses in function notation. So 2 units to the left is going to be f of x plus 2. If you're adding, it goes to the left. If you're subtracting, it goes to the right. It's a little bit backwards of how you might think it would be, but that's how it works out, okay? So then I'm going to input this quantity into the function. So the input is where the x is. That means I'm replacing that x with the quantity x plus 2. So I've got the absolute value symbol, then the quantity x plus 2, and I've still got the minus 1 there, and plus 3. And then we just want to simplify this. So all we can do inside the absolute value is combine the 2 and the negative 1. So let's see, we'll get absolute value of x plus 1, and I've still got the plus 3 on the end there, and there is my solution. That's all we can do. You can't combine the 1 and the 3 because one of them's inside the absolute value and one isn't. Okay, now we're writing function h. We're going to go, it says 3 units down, so I'm going to take the original function and subtract 3 from the whole function, not from the input, but from the whole function. Okay, so this one I don't have a new input, but what I can do is substitute in what f of x equals. F of x is equal to all of this. So, all right, substituting in absolute value of x minus 1 plus 3, like that, and I still have the minus 3 on the outside, okay? And this would look the same without parentheses, so then I need to combine the 3 and the negative 3. Well, 3 minus 3 is 0, so that means I'm just left with absolute value of x minus 1. And there's function h. Okay. The last two are reflections, so k of x, function k, what are we going to do? We're going to do a reflection over the x-axis. So over the x-axis, we're going to take the opposite of f of x. Okay, so no new input here, but again, we can substitute in f of x. Now, it's tempting to just look at the original function and put a minus in front of it, change the sign like that, but that's actually a little bit incorrect because when we substituted in this quantity, okay? So when we distribute this negative, we can't distribute inside the absolute value, so there is going to be a negative in front of the absolute value. But also we want to change the sign of the 3 because we can distribute a negative out there, and that's what we want to do. So I've got negative absolute value of x minus 1 minus 3, not plus 3. Okay, so you want to change the sign of the absolute value part, but then also of the 3 that's hanging out at the end as well. Okay. All right, and then m of x, we're reflecting over the y-axis, and that means we're going to change the input. We're going to take the opposite of the input, so f of negative x. All right, so my new input then is negative x, so I'm going to the function, and where the x is, I want to replace that with negative x. Okay, that's all that changes, and so there's not much simplifying I can do on this one. So I'm just going to write that like so. And there is my solution on this one. The book likes to sometimes change the signs inside the absolute value. So especially on ones like this where the first term inside the absolute value is negative, the book likes to rewrite this answer. I don't really see the point of that, but you could take this function here and say, okay, that's the same as this. I took the opposite of what was inside the absolute value of both terms inside, and that would be equivalent. So this is a legitimate answer as well. It's kind of a sideways move to me, so I usually don't bother with it, but there you go. Okay, that's the end of the warm-up. See you next time.